Alright, this is a problem that we might see in a second grade classroom. Our problem says, Joey had 17 books. Tiffany gave him some more for his birthday. Joey now has 22 books. How many books did Tiffany give him? Okay, so we can see that we're going to use the join set model today to solve our problem. We can see we have a start amount and a change amount that equals our result amount. So for joining, we can see that the arrow points up. And for joining, we are going to physically put this amount into this amount. So our change amount will go into our start so we can get the result. And we can see that I have the arrow pointing up for us already. Okay, so let's read our problem and put in our amounts where they go. Okay, so it says Joey had 17. So he started with 17 books. Okay, and we'll show that with base 10 blocks also. So we have 10, 11, 12, 13, 14, 15, 16, 17. And he got some more for his birthday, so we don't know that amount yet. So I'm going to write a question mark. And now he has 22 books. So after Tiffany gave him some, he had 22. So our result is 10, 20, 21, 22. And we'll go ahead and write that number too. Okay. So usually people think that joining means we just add, because we would take this amount plus this amount to get this. But for this problem, we can't do that because we can't add a question mark. We don't know how much that is yet. So that's a misconception that you can only use addition when it's joining. For this problem, and for several other problems, you have to do subtraction to find the change amount. So we would take our result number, 22, and our start number, 17, to try to figure out the change amount. This number right here. So when we do that, we subtract 22 from 17, and we end up with 5. So let's write 5 in our change amount. And let's go ahead and put 5 units or ones over here to show our 5. So now we need to physically move these 5 up into here, like we said, the join problem, how that works. And so we'll see if this is going to be equal to this. So we have 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. We know that when we get to a new 10, we don't need these units anymore. We need to regroup it into a long. So we took those 10 and we got a 10 long. So now let's see. We have 10, 20, 21, 22 for the start amount. And let's see if that's equal to our end amount, the result. We have 10, 20, 21, 22. So that's right. We had to use subtraction to get the answer, but we still ended up joining these two numbers together to get this number. So keep in mind that joining is not always just addition. You can also subtract to find your answer. Alright, second grade, I have another problem to show you today. This time it is a separating problem. We're going to use the separating set model. Our problem says, Peyton has 24 candies. He shares some with Tanner. He has 16 left. How many candies did Peyton share with Tanner? So you can see our separating model has a start, a change, and a result also. But the arrow points down towards the change this time, because we are going to start with an amount and then we're going to take some away. So our start amount, and then we take away some for the change, and then we end up with our result. So let's go ahead and relook at the problem and write down our numbers. So Peyton has 24 candies to start with, so we're going to put 24 here, and we'll show that with base 10 blocks also. So we have 10, 20, 21, 22, 23, 24. And the change says he shares some with Tanner. So we have another question mark here. And then he has 16 left. So let's go ahead and put the 16 base 10 blocks. We have 10, 11, 12, 13, 14, 15, 16. And we'll write that right here. Okay, So we know that we are using the separating method because we're taking some away from this. So I need to turn my little arrow around to show that we're going to take some away from the start to put it into the change. Okay. So, to figure this out, we can't do 24 minus question mark, can we? No. So we have to rearrange our problem a little bit. We need to take 24, our start number, and we're going to take away 16, or subtract 16, to try and figure out this change. Okay? We're going to take away, or mark out this 2, 10, and make it 110 so we can carry it over here, regroup it over here, not carry, regroup it over here, and we're going to have 8 ones left and 0 tens. So it says our change is going to be 8. So let's see if that's right. And this time, we're not just going to grab some to put over here. We need to subtract from up here. So we need, there's not enough ones to make 8 down here. So we're going to regroup this 10 into 10 ones. So we have 10 here. I already counted them out. And then we have a lot of ones now, so we have enough to take some away and put it in the 8. So let's go ahead and take away 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so we took away 8. Let's see now if our start amount is equal to our end amount. We have 10, 11, 12, 13, 14, 15, 16. 16 here. 10, 11, 12, 13, 14, 15, 16. And we have 16 there. So those are equal to each other, right? Yeah, they are. Okay, so we had 24, and then we took away 8, and we got 16. And I want to tell you something today. The reason I didn't give you this change amount, and I made you kind of work backwards to figure it out, is because I don't want you to always think that this equal sign means the answer is coming up. Because it didn't mean that it was coming up in this case. Because we had 24 minus question mark equals the amount already. So the equal sign didn't mean the number or the answer was coming up this time. And that's what I want you to remember. The equal sign doesn't always mean that the answer is coming up. The equal sign means that this side has to be equivalent or equal to this side. So we had to figure out this number to make these two sides equal. And if you just always think that the equal sign means an answer is coming up, then you wouldn't really be able to figure out how to solve this problem. And that's a misconception that I don't want you guys to have. So I just want you to remember that the equal sign means that this side has to be equal to this side.